Hello everyone. So today I am here to present CodeCamp on the topic browser-based load testing with Grafana K6. So let's first discuss the agenda of this session. So first we are going to discuss what is load testing and why load testing is important, and we will see some of the real world examples of performance failure that happens over the last decades. And after that we will discuss what is browser-based testing and its key features. Then we will see why we need browser-based testing and how it benefits over API testing. Then we will see some of the advantages and disadvantages of browser-based testing. After that, we will discuss the selection of tools for browser-based testing. Then we will see introduction to K6, and in this part we will going to discuss K6 browser module, use cases of browser testing. Then we will see some of the um, basic scripts that we can do for browser level testing. Then we will see how we can execute browser level K6 scripts. Then we will understand the uh, browser matrices outputs that we get after the execution. Then we will see we have what types of reporting mechanism we have in the K6. Then we will see page object model in K6 and its implementation. Then we are going to discuss what are the tips of what are the tips that we need to write browser level scripts. Then some of the pitfalls to avoid when we are performing browser based load testing. Then some of the best practices, and then demo. So moving to the first slide, let's discuss what is load testing. So the goal of load testing is to check how well the application can handle a specific amount of concurrent users or transaction while maintaining acceptance performance levels. So basically, what is load testing is um, when we check here that how well our site performs when we are going to apply many users at the same time. So now let's discuss what is why load testing is important. So load testing is particularly important for several reasons. First is resource planning. So load testing helps in planning the required resources such as server capacity, bandwidth, and database performance. And this allows organization to allocate resources effectively and avoid unnecessary expenses. Then second is performance optimization. So here load testing provides insight into the application performance under different conditions by simulating various use cases. So this information is very valuable for optimizing the code, databases, and infrastructure to ensure optimal responsiveness. Third is user experience optimization. So here load testing ensures a positive user experience by preventing issues such as um, slow responsive times, downtimes, or crashes during the heavy traffic. So this is also very crucial for retaining users and maintaining a positive reputation of the organization. Fourth is identifying performance bottleneck. So here load testing helps in identifying performance bottlenecks by ensuring that your application can handle its expected user load without any degradation in the performance of the site. Fifth is reliability and stability. So here, with the help of load testing, we can identify and address the performance bottlenecks, um, and which results in which results in improving the reliability and the stability of the application. And this is essential for meeting the organization expectation when and when an end user is um, like using the site. Let's move to the next slide. So let's discuss some of the real example of performance failures. So over the past years, we have come across the scenarios where performance glitch led the organization to huge business losses. So I am going to discuss some like two of the different scenarios. So let's discuss with Lloyd's case. So they have experienced a system failure when multiple users trying to withdraw cash at the same time. So why this has happened? Uh, this has happened because they haven't done all the edge cases that is needed when user is trying to withdraw the caches. So this results in the performance failure, and this also results in the business loss of the organization. Second, we have the example is healthcare.government. So after the first day of the release, they face a performance failure in the system. This is happens due to they haven't done any performance testing um, before the release. So these are the two of the real world examples that we have for performance failure. Let's move on the next slide. So here we will discuss about browser-based load testing. So basically, browser-based load testing verifies the front-end performance of an application by simulating real users using a browser to access your website. And unlike traditional load testing tools that operates on a service level or the protocol level uh, devices, browser load testing interact with web application just like real users do using web browsers. So let's take an example. So a browser-based testing scripts might include instruction that real users do, like navigate to a page and click on a button and type out text on a form. Those user actions then trigger underlying requests on the protocol layer or maybe microservices layer, but only uh, user actions are scripted in browser-based testing. Now let's discuss some of the key features of browser-based load testing. First is realistic user scenarios. So browser-based load testing simulate user interactions by loading pages, uh, clicking buttons, filling forms, and navigating through the application. This approach provides a more accurate presentation of how real users interact with the system. Second is JavaScript execution. Since modern modern web applications heavily relies on JavaScript for dynamic content and interactions, browser-based load testing tools execute JavaScript, ensuring a comprehensive evaluation of the application that we need in the performance scripts. Third is browser diversity. So um, browser-based tools can emulate different browsers and devices, allowing developers to understand how performance varies across various platforms. This is very crucial for delivering a consistent user experience across different devices and browsers. Last is load distribution. Here, browser-based load testing distributes virtual users across different browsers and instances, simulating a diverse user base and providing a more realistic load on the web application. So these are some of the web key features that we should include in our browser-based load testing. Now let's move on the next slide. So why browser-based load testing? So here we are going to discuss why we need browser-based load testing. So first is realistic simulation of user behavior. Here, browser-based load testing allows you to simulate how real users interact with your web application. This includes rendering an HTML, executing JavaScript, handling cookies, and deals with other client-side aspects. Second is handling dynamic content and Ajax. So right now, so in the current time, many of the web applications heavily relies on dynamic content and Ajax. So Ajax here um, like understands asynchronous JavaScripts and XML. So this provides a smooth, interactive user experience. So here, browse-based load testing tool can accurately simulate these dynamic behaviors in the script that we write with any tool. Third is identifying client-side performance issues. Here, browser-based testing helps in identifying bottlenecks related to client-side rendering and interactions. This includes measuring page load times, rendering times, and other methods that we are going to discuss later. Fourth is scripting flexibility. So browser-based load testing tools often provide scripting capabilities that allow testers to script complex user scenarios and interactions. This flexibility is very crucial for simulating diverse user journeys through an application. Fifth is multi-setup transactions. So browser-based tools can simulate multiple step transactions and user flows, allowing testers and the developers to evaluate the performance of the entire user journey uh, rather than the individual requests that we see in API-based load testing. Sixth is user-centric performance matrices. So browser-based load testing tools typically generates performance matrices that that are more user-centric, such as load page times, time to first byte, time to interact. So these are some of the matrices that are valuable for understanding the end user experience. Seventh is measuring front end performance. So this is very essential in browser based load testing for accessing the performance of front end components, including how quickly pages are rendered, how efficiently assists are loaded, and how responsive the user interface is. Last is testing across different browsers. So browser-based load testing allows the organization to test their application across different web browsers and web versions, such as like Chrome, Firefox, Edge. We can use our script in different browsers and check if our scripts are failing. Then we definitely have performance issues. If they are not failing, then we are good to go for deployments. So let's move on to the next slide. Browser-based testing over API testing. So here we are going to discuss uh, that why we choose browser-based testing over API testing. So let's first discuss API-based testing. So the API-based testing scope is like it targets the underlying application servers, meaning it calls each request of the individual services. Like if we have different microservices, then we will um, like test all the request there individually. But on the browser based testing, we measures end user experience at the interface level, and here we check how our page elements appears or not. Second is testing environment. So in API based testing, it is conducted on application servers in a production like setup, whereas browser-based testing requires a fully integrated environment with UI. So let's take an example. So here on the API-based testing, we can do this testing on the production level setup, like the UAT environment. For the browser-based testing, we will be needing a fully integrated environment with our application. Third is flexibility. So API testing allows targeting specific components, whereas browser-based testing primarily focuses on the user level interface. Fourth is early issue identification. So on the API levels, there might be a chances that we will get some performance issues in the early stages, whereas in the browser-based testing, we will get bottlenecks at the early stages on a microservices levels, like on the like when we are performing any action on the UI, then it calls some APIs. Then we will see if the API's calls uh, are quick or not. So it depends on the response time of the APIs. Fifth is response, sorry, resource intensity. So in API testing, we have less response resource intensive compared to the front end, whereas on browser-based testing, we have more resource intensive, especially for automation. Like here, we can provide different data at different time for different users. Last is user suitability for load testing. So API-based testing is more suitable for generating high loads on the server, whereas browser-based testing tends to be easier to run on a small scale due to resource constraint. So we can also generate a higher load on the uh, browser-based testing when we are testing large applications. So let's move on the next slide. So here we are going to discuss some of the pros and cons of browser-based load testing. So let's first discuss user perspective. So real world end users interact with the website using browsers. For example, in a real Chrome browser, browser-based load testing allows you to load test your website with regular Chrome browser and understand the real world user behavior. Second is simple scripts. So for creating browser-based load testing scripts, you don't need to have in-depth knowledge of underlying protocols. For example, if you want to create a login action, you just need to add the username and the password to fill in, and which button to click to proceed. You don't know the technicalities or of authentication of protocols such as. Third is reduce test complexities. So unlike other traditional load testing methods where you need parameters and values to pass, in browser-based load testing, it is very easier to create and initiate with streamlined scripts. And we can use JavaScript in this. Fourth is front-end optimization. So browser-based load testing allows you to collect the most accurate real-world data, such as network and request delays, as your user also interacts with your website using a real browser. So this helps in automating your front end. Last is low maintenance. So simple scripts and less complicated test means easier maintenance and more agility for load testing. For example, in our logging example, if we exchange the authorization protocol, then the login load test doesn't need to be changed as it is not effective by that. Now let's discuss the disadvantages or cons of browser-based load testing. So first is high memory and CPU usages. So here browser-based load testing use a real uh, Chrome browser. For example, it requires higher CPU and memory to create instances for the expected load. However, this should not be a problem if you use a cloud-based load test platform. Second is occasionally longer runtime. So browser-based load testing involves rendering the complete website UI in a browser instance rather than the simple API request response recording. So this can take longer than other load test approach. Here, some of the times we will see like we will get some um, longer runtime for the locators that we are not able to find in the script. So this result in the longer runtime. So this happens sometimes, not every time, if you have the correct locators of every element. Third is limited browser environment capabilities. So while you can test many browser-based scenarios in headless browser testing, it is not enough to get a complete picture of real-world users who are using real browsers like Chrome. Let's move on the next slide. So how we can select the tools for browser-based load testing. So we can select the tools for browser-based load testing based on the project preferences. Then second, based on these points that I mentioned below. First is ease of use. So we should consider the learning curve and the ease of use for our team, especially if they are not experienced with a particular tool. Second is scripting language. So we should choose a tool that supports a scripting language that our team is comfortable with, and that we can align with our project requirements. Third is user simulation. So we should evaluate how effectively the tool can simulate real users interaction, and this is very crucial for our realistic load testing. Fourth is integration. So we should also check whether our tool has integration capabilities with other CI CD tools or not. Fifth is reporting and analysis. So we should look for a tool that provides a detailed and meaningful reports as well as options for result analysis. Sixth is cost. So we should always consider the licensing cost or any associated cost with a tool, especially if you are working within budget constraints. So let's move on the next slide. So here I have used K6 as this is basically a new tool. K6 has currently introduced browser-based testing. So we are going to use K6 as our load testing tool and performance tool. So Grafana K6 is an open source load testing tool that makes performance testing easy and protection for developers and DevOps teams. So K6 benefits K6 comes from a vibrant community providing support and sharing scripts and contributing to continuous improvements. And it is compatible with various systems and environment, making it very suitable for a wide range of applications and use cases. And K6 empowers teams to identify and addresses performance issues early in the development life cycles, ensuring um, robust and scalable applications. So here we are going to leverage K6 browser module. So K6 browser module brings browser automation and end-to-end web testing while supporting core K6 features. So with the help of K6 browser module, uh, it happen it helps us to provide browser automation end to end for web applications, and it enables us to get insight from your front end application during performance testing. And we can mix with the help of K6 browser module, we can mix browser level and protocol level test in a single and unified scripts, and this can simulate the bulk of your traffic from your protocol level test and run one or two virtual users on a browser level to mimic how a user interact with your website. So here we are leveraging a hybrid approach to performance testing where uh, we are testing both protocol level and browser level test in a single script with multiple users. Browser modules offers a unique solution as we don't have to use separate tools to test our front end and back end systems. And it also offers a simplified experience and aggregated view of performance matrices. Let's move on the next slide. So what use cases we have for browser testing? So the main use case for the browser module is to test performance on the browser level, and browser level testing provides a way to measure how user experience how a user experience the site and find issues that are difficult to catch on the protocol level. And here I have mentioned some of the questions that browser level testing answers. First is when my application is receiving thousands of simula- simultaneous requests from the protocol level, what happens to the front end? So from the protocol level, we can simultaneously request, we can check the simultaneous request, and on the front end we can also check these. Second is how can I get matrices specific to browsers like total page load time. So when we are executing our browser level scripts, then we will be getting some web vitals, which is also the matrices of the browsers that we are using. Third is all my elements interactive on the front end. So browser level testing also answer this question as we are uh, we are adding all the elements, all the actions that we are going to perform in the user scenario. So this also helps if our element is interactive or not. Are there any loading spinners that takes a long time to disappear? So while executing our browser-based load testing, we will also get some response times and page load time there. So here we will see uh, if our page is taking long time or not. So let's move to the next slide. So here's the basic browser level K6 script that we can use. So here first we can import uh, our browser object from the K6 experimental browser module. So this object is used to interact with web browsers, web pages in your performance scripts. Second, we are defining our options object, which specifies the configuration of which specifies the configuration of the K6 test. And here you can see scenarios. So this this section defines different test scenarios that we are going to perform in our scripts. And you can see executor. So here we have provided the value constant views. So it means that in the given duration, um, all the uh, all the nu- all the virtual users will get executed at the same time in 10 in the given duration. Second is options. So in in options we have defined our browsers like type Chromium. So in the right now K6 only supports Chromium, and in the future they will be like going to support Firefox or Edge or other browsers. Then also we can also define thresholds here that I will be showing on demo. Last is we are exporting a default asynchronous function. So this function will be executed by K6 during the performance test, and inside the function we have like created a new page using browser.newPage, and this 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 represents virtual users interaction with a new page, and then we are just going to the website and closing the browser. So how we can run execute our browser level K6 scripts? So with this command K6 browser headless equal to false, K6 run and your script name. So with this see we can see a browser gets opened, and we can see all the actions that a normal user will perform, and we will get a summary report for this. Here you can see all these matrices. So this is for the uh, this is for only when we are providing headless as false. So if we are providing headless as true, then we will see then we will not see opening, then we are not going to see that our browser get opened and these results. We are only seeing the headers result there. So let's discuss the browser matrices output. So here, whenever our browse test finishes, K6 provides a top-level overview of the aggregated browser matrices output that I have mentioned here. So here you will see browser data received. So what it means is like this static is related to the data received by the browser during the test, and browser data sent. It means that the data sent by the browser. And here we have the matrices, uh, web matrices that we are only see when browser test gets executed. So what browser uh, web vital CLS mean? It's um, cumulative layout shift, and what FCP means is con first contentful paint. Third is LCP, which is largest contentful paint, and last is time to first byte. So these are some of the vitals and the matrices that we see on we see for browser tests. Then the data received and the data sent, then the iteration duration. So here only one iteration gets executed, and we have the virtual users one only. So these are the this is the example of for the browser matrix output. Let's move to the next slide. So reporting mechanism. So in the earlier slide, we have seen the summary report, and I will be showing the HTML report later in the demo. So let's first discuss what is summary report and what is HTML report. So summary report provides a high-level overview of the key indicators from your test. It's it is very useful for quickly understanding for the overall health of your system during the test. So summary reports basically involves total number of views, duration of test, responsive times like 50, 95, and 98 percentiles, request and responses statistics, error rate, and virtual user distribution. Also the matrices that we have shown earlier. And in the HTML report, like HTML report is basically more detailed and provides a visual representation of the test results. It includes various graphs and charts that can help in depth analysis, and it also involves response time over time trends over time, uh, RPS trends, latency distributions, error rates, virtual user activity over time, custom matrices, and their trends. So these are two of the popular reporting mechanisms that we are going to see in K6. Let's move on the next slide. So leveraging page object model in K6. So what is page object model? So page object model is basically a design pattern that creates an object repository for storing all web elements. So as you can see in the diagram, we have web pages for home page and login page. And how we can utilize page object model is in our scripts, we are going to create a page folder, and in page folder we are going to create specific page uh, classes. Like for home page, we have created a home page object model there, and for this we will like write all the elements or locators that we are going to perform for the user scenario in our scripts. And page object models helps reduce in code duplications, and it also improves test case maintenance. Um, and the main idea behind the page object model is to abstract the details of the user interface components and their interaction with the underlying code, and making the um, automation code more modular and readable. So Let's move on the next slide. So this is the implementation of the page object model in K6. So here I have used the web dummy website, which is source demo. So here what I have done is like I have created a pages folder, and in the pages folder uh, I have created a class homepage where I have used the constructor for every for every locator. Like I have added all the locator that we will see on the page itself, like username, password, submit, and I have also mentioned the website name. And test uh, on the test itself, I have just imported the browser and the expect libraries and sleep and homepage class there, and mention the um options there. And here you will see I have just created the browser new page, and and after that we are calling all the elements from the homepage class in our test, as you can see on the line number 8, 26, 27, 28. So here we are performing the login functionality. So this is how we can implement page object model in K6 scripts. So let's move on the next slide. So so what tips for writing browser level scripts? So here are some tips that I have mentioned, some tips that we can use in our browser level testing. First is script user actions, not request. So here we should determine what a user might do for a particular task, and how it can interact with elements in our browser script. For example, script what buttons the user click on. Second is identify unique selectors. So right now K6 only supports two of the selectors, which is uh, CSS selectors and uh, the XPath selectors. So once you identify which page elements a user interact with, and you use these selectors uh, while go to the dev tools in your browser to find a unique and static and simple way to identify each element. The script needs selector to find the right element to interact with. Third is use element to verify responses. So after performing every action, use locators to search for an element on the pages uh, that you would like to find, and this helps in the verification of the script that the user has reached the expected page. Last is take a screenshot for every action while debugging. So this is one of the uh, advantage of browser based testing, is that the ability to take a screenshot. So we can use page dot screenshot in every uh, in so we should use page dot screenshot in our scripts while performing um, any action there. So like in Selenium or other tools, we have to write a for whole function or maybe method there to perform screenshots. But K6 provides us a way, just a single line, page dot screenshot, that we can use to take screenshot automatically. So let's move on the next slide. So what are the best practices for browser-based load testing? First is identify business goals. So we should clearly outline our testing objectives, that and determine what aspects of your web application you want to evaluate, such as response time, throughput, error rates, and resource utilization. So understanding our goals will help us to design a effective test scenario. Second is script realistic user scenarios. So we should we should uh, oh, develop realistic test scenarios that user mimic actual user behavior, and this includes navigating through pages, submitting forms, and interacting with dynamic content. The script should um, simulate a variety of user actions to represent different user journeys on your website. Third is choose a suitable tool. So uh, we should choose a reliable browser-based load testing tool that suits our need. So right now in the market we have different tools like Apache JMeter, Gatling, Selenium, K6, Puppeteer, etc. So we can choose our tools based on our project needs and uh, ease of use, scripting capabilities, reporting and integration with other testing tools. Fourth is continuous monitoring. So uh, while executing our performance testing scripts, we should always monitor the test as it helps us to find bottlenecks based on the matrices such as uh, web vitals, error rates, transaction rates, etc. Fifth is ramp up gradually. So we should not provide uh, a high load directly to the application while executing our performance test, as this results in not finding any issue. But if we gradually increase our number of virtual users to simulate a realistic user load, this approach helps us identifying the breaking point and the scalability limits of your application of our application. Last is always keep end user in mind. So keeping the end user in mind is very crucial while conducting browser-based load testing, as the goal of our load testing is to ensure that your web application delivers a positive user experience even under heavy loads. So let's move on the next slide. So what are the common pitfalls that we need to avoid in browser-based load testing? So first is ignoring realism. So testing with unrealistic scenarios may provide an inaccurate insights into how our application performs under actual um, user condition. So we should always strive to replicate only real world scenarios to ensure meaningful results. Second is neglect data variability. So failing to incorporate diverse data sets in our testing can lead to incomplete evaluations. So we should always ensure that your data set should cover a wide range of scenarios to uncover potential performance issues related to different data inputs. Third is inaccurate monitoring. So lack of real time monitoring can lead in overlooking critical performance issues during testing, and continuous monitoring with tools like Grafana allows immediate detection and response to anomalies. Fourth is overlooking isolation. So not isolating the testing environment may introduce interference and affecting the test accuracy for the other users. So we should always ensure that the testing environment is separate from the production and it is always dedicated solely for the performance testing. Fifth is poor documentation. So poor documentation can hinder collaborations and troubleshooting efforts while we are performing any browser-based load testing. So we should always document our test scenarios, configurations, and results thoroughly, so that anyone who is new to the team can check what is happening here uh, and how he can perform performance testing or load testing there. Sixth is incomplete reporting. So reports lacking key sites may impede the identification and the resolution of performance issues. So we should always ensure that our reports are comprehensive, providing a detailed overview of performance matrices, trends, and recommendations for improvements. Uh, Seventh is limited test execution. So short test duration, if we are running short test, then it may not reveal long-term performance issues that we will see in current time. So we should always consider running a extended test to identify how our application works under heavy load. Eighth is ignoring user experience. So we should not solely we should not solely focus on uh, server matrices without considering user experience. As if we are only focusing on the APIs based load testing, then might be a possibility that on the browser based testing as a as a real user, we are going to find different issues while under heavy loads. Last is static parameterization. So failing to dynamically parameterize variables may result in unrealistic test scenarios. So dynamic parameterization is very crucial for simulating real world scenarios where data and user states change dynamically. So let's move on the next slide, which is demo. So let me, yeah. So here is a small example of test K6 messages. So here I have created a page object. I have implemented page object model for our browser-based load testing. So in the home page, you will see one of the homepage class which contains all the elements for the login element, for password element, for submit element, and for logout. And this is our site test.k6.io. So and here I am importing the browser from the K6 browser module, and I'm importing the check object here from the K6 and sleep. And this is our homepage class that we have defined in the pages. And this is for HTML reports that we will show later after execution. So here I have um, created an option object. Here I have defined the scenario that shared iterations. In the shared iterations, uh, for three iterations, we have two virtual users every time. And while letting this is while using shared iteration, you should always remember that the iterations value should not be less than the virtual users value. And here we are using Chromium, as K6 only supports Chromium right now, as it is new for browser-based load testing. And here I have uh, added some custom matrices, some custom thresholds. Here we are checking the rate should be equal to 1.0. If our rate should be greater, should should get greater than 1.0, then we will see in the report that our checks get failed. And here I am providing uh, um, two of the matrices, browser web vital LCP, which should be less than 1000 for 90th percentile, and here we are checking the same. So right now, for the threshold thing, uh, cases only support the URL validation. not the if we are going to group the every thresholds, then we might not see the matrices there. And here I have I'm going to the website and I have added all the screenshot for every element. So this helps in the debugging for the developers and the testers uh, to for catching performance bottlenecks. So let and here I have used uh, handle summary function for HTML reports. So we show I'm going to execute it. So this is our command. I'm going to run in the browser mode. So this is our command K6 browser headless equal to false and K6, and this is my main test. So here you can see we got some warnings there uh, for the page dot close from the JavaScript. And here you will see all the matrices that I have discussed earlier in the slides. So this is the browser data that the browser has received and the browser has sent. And this is the browser request. And here you can see all all the requests gets passed. We have 21 requests and it got passed. And this is the browser web vitals, CLS, FCP, FID. So here you will see browser web vital INP and we have the URL here. So this is the threshold that I have provided uh, early in the scripts, and this is the LCP, TTFP, and this is check that we have provided in the threshold. And here you will see all of them are failed. No, all of them are passed. Sorry. And you will see on the left side that we have a screenshot for every page. This is for home page. This is for username that we are adding. So if something fails here, that then it will be very helpful for the developers and testers to check and for debugging purpose. And for the HTML report, so one second. Um, yeah. So this is the HTML report that we will see uh, after execution. So here it also contains all the matrices that we have seen in the summary report. And here you will see other stats, which is checks, iterations, virtual users, request, data received. So data request, you can see request when you are performing API based testing. So if you are executing APIs, then you will see all the requests and what is the rate for that and what data they have received and what rate uh, for them. And here all the checks in the groups. So right now I have provided only one check there, and all of them are passed. So so anyone have any doubt? I don't think anyone has any doubt. So thank you everyone.
Thank you, Himanshu. And guys, I'd like to request you again, if you're having any doubts, then this is the right time to get those doubts cleared by Himanshu itself.
Thank you, Manju. That was a nice session.
Fine. So thank you, Himanshu, and thank you everyone for joining this session. You guys will be getting an email for the CodeCamp assessment after the session, and will request you all to please kindly assemble the assessment. With this, I guess we are going to wrap up from here, and hope you guys have a good day ahead. Thank you, everyone.